Hey guys, Mr. Middleton here. Today we're going to find areas of triangles and parallelograms. At the end of this video you should be able to find the areas of triangles and parallelograms. Alright, let's start straight off something you probably know already, that the area of a parallelogram can be found by using base times height. Base times height. Okay. The base of a parallelogram can be any side, but each side has a corresponding altitude. Okay, typically with these problems, what happens the most, and the altitude is just the height. Okay, so any base has corresponding, or any side can be a base, and any altitude is its height. Okay, the length of the altitude is its height. Okay. So typically what happens, the biggest mistake that happens is people are say, oh, we got to find the area of a four-sided figure, one side times another side, 2.5 times 2. Okay, that is not the case in parallelograms. If it's a rectangle or a square, then it can work out, but not for parallelograms in general. So in this parallelogram, which lengths could represent the base? The base can be any side, so 2 or 2.5. Okay. The one that makes sense to use in this problem is the one that has a height or altitude that corresponds with it. The altitude, 1.8, corresponds with 2.5 as the base. Okay? And we know that because of the right angle symbol. Okay, that tells us that it's the altitude, not just some other line. Okay, and so therefore we can find the area of this triangle by doing base 2.5 times height 1.8, which is 4.5 meters squared. Okay, now, next question, and this isn't written in the problem, it says, what is the altitude associated with the other base? Okay, now, what we know about this figure right now, from what we've found so far, is that our area is 4.5. Okay. We also know that we can find the area by doing base times height, and that any side can be a base. So our equation then could be 4.5 equals base, which we know the other base is 2, times height. So to find its height then, we divide by 2, and we get 2.25 equals h. So the altitude associated with the other base is 2.25. Alright? Alright, let's look at some more examples down here. So let's find the area of each parallelogram. Remember, what matters with area is base times height. Okay, so we can use any side as the base, but we want to use the one that we have a height given. Here, I have a height given. My height is 3.5. You can tell by the perpendicular thing. Okay, my base, though, is just the side of the figure. My base here is 2. 2 times its height, 3.5. 2 times 3.5 gives us 7. And I'll just use 7 centimeters squared. I should have labeled that as well. Okay. Alright. Second problem is a little bit harder. People always get thrown off by the lines outside of the figure. Got to think about that a little bit, but let's look at this together. For this problem, it tells us that FC is 10. Okay, so make sure you're always looking around for the information they gave you. FC is 10. Now, what is FC? Is FC a side of the parallelogram? No. Notice this right angle here, and it's telling us the distance from one base to the other. Even though it's written out here, it would be the same if we drew it in here. This is just written out here for clarity so you don't get it mixed up with any of the other lines. Okay? So we can tell that this height is 10. Okay? And it's associated with the base 13. Again, we can find area, base times height. So the area of this will be 130 inches squared. Alright? Alright, flipping to the other side. Number 3. Alright, now it gets a little bit more challenging because instead of just having our height given to us somewhere in the diagram, we have to figure it out. And we'll figure it out actually using our special right triangle. So hopefully you looked at those and you kind of remember those, because like I said in our previous lesson, it'll make your life a little bit easier for you. Okay, so notice here, we want a height. We want to be able to find a height here. Either height will do, but they kind of give us a clue here. This angle's 60. Okay, so what I'm going to do, I'm going to draw a line. And I'm going to pretend that my line's a straight up line so that I have a 90-degree angle here. Okay, this helps me because now I have a 30, 60, 90 triangle. And because I know the ratio for 30, 60, 90 triangles, my hypotenuse is 2s, this is s, this will be s times radical 3. It'll make my problem or my life a little bit easier. So 2s is 8, and so I know that this side will be 4, and this side then will be 4 times radical 3, or 4 radical 3. This is my height. My height is 4 radical 3, my base is 12, so 12 times 4 radical 3 will give us 48 radical 3 meters squared. Okay, and so that's how we write the answer. Anytime that they give us like round to the nearest tenth or something, we could just punch that into our calculator. Okay, but writing in this way and knowing how to do it this way, a little bit easier for us. All right, number 4, a little bit challenging in the sense that it doesn't just come out and say, hey, use a special right triangle. So we have this 135. Okay, so we kind of have to use or know what a parallelogram is. And we know a parallelogram has 2 pairs of parallel sides. Okay, and that means that their angles here are same side interior angles. It means they're supplementary. So if this is 135 degrees, these two add up to 180. This has to be 45 degrees. Okay, and that helps us because now I can draw my altitude. Boom, boom. And I know I have a 45, 45, 90 triangle. Now, also parallelograms, I know that opposite sides are congruent. So if this side is 4, this side has to be 4. And so, again, with my 45, 45, 90 triangles, I know that I have S, S, S radical 2. If you don't have these triangles down in your memory, it's going to make life a little bit harder for you, so make sure you spend some time to get those down. Alright, so 4 equals S radical 2. Okay, I need to find out what S is so I can know the height of this parallelogram. So I'm going to divide by radical 2. S equals 4 over radical 2. I have to do my fancy 1. And I got 4 radical 2 over 2. And that will simplify to just 2 radical 2. So S is 2 radical 2. And now I can use that along with its corresponding base. Its corresponding base in this case is 8. Say, okay, 8 times 2 radical 2 will give me its area, which is 16 radical 2. Alright, so area of a parallelogram. Remember that parallelograms are not necessarily rectangles and squares. You will have to find the altitude that corresponds with the side that you want to use. Okay? Alright, area of triangles. You can find the area of a triangle by using 1/2 base times height. Okay, why is it 1/2? Every triangle is half of a parallelogram. Parallelogram. Okay, if we wanted to draw, let's just say a slash here, I could cut that parallelogram in half. Okay, and that would be 2 triangles. See that? And so 1/2 base times height is 1/2 of a parallelogram. Just using that. Okay, so just like in a parallelogram, the base can be any side of the triangle. And the height or altitude must be perpendicular to that base. Perpendicular. Alright. So let's find the area of each triangle. So first one should be pretty simple. Notice they gave us all the sides, so the toughest part for us is just deciding where the height is and what side corresponds to it. So here, our height here is 5, perpendicular. Distance from this to the other side. Its base is 14, and so my equation then will be 1/2 base times height. So 1/2, 14 is 7, 7 times 5 is 35. So 35, we'll just say units squared. Alright, number 2, again, please don't get confused by these other numbers. what's 3 measuring? Is 3 measuring the base of a figure? No. Okay, 3 is not measuring the base of a figure, so don't use it. This isn't 13. Okay, you can tell by the dotted lines that's not supposed to be included in our triangle. Our base is 10. We see that we're given this height of 6. It doesn't change that it's 6 because it's showing out here. It's still the height. And so we can find the area by doing 1/2 base times height. 1/2 10 is 5. 5 times 6 is 30. 30 feet squared is our area. All right. Final. All right. Final thing. Oops. Sorry. Here. It says the wall of the garage shown below can withstand 7,500 pounds of force. How fast would wind have to be traveling to knock down the wall to the nearest unit? Okay. So they tell us this equation, F force equals 0.004 area of the structure times velocity squared. So obviously our point here, we need to find the area of this structure. The area of the structure can be found by finding the area of a rectangle and the area of a triangle. So the area of this rectangular parallelogram, I'm going to assume that it's a rectangle. Base times height, 20 times 20 times 12. That gives us 240 for this figure. The area for the triangle, base times height, again is 20 is our base, times height 6, so 120, 1/2 of that will be 60. So the area of this structure will be 60 plus 240, which is 300. Okay, so that's the part from this lesson. And now the rest of it is just being able to use an equation and make it make sense. So we know that this thing can withstand 7,500 pounds. Okay, and in order to knock this thing down, our speed or whatever this other side has of the equation has to be greater than 7,500. So we have 0.004. Our area is 300 v squared. So we're really finding v squared here. All right, handy dandy calculator. So 0.004 times 300, so I can find out what that number is. That's 1.2. Okay, 7,500, 1.2 v squared. 1.2 is multiplying v squared, so I'm going to divide 1.2 on both sides. So 7,500 divided by 1.2 is 6,250. And now, in order to get v by itself, I'm going to take the square root of both sides. And that's 79 to the nearest unit, so 79. Okay, so this thing would have to be going, let's say, 79 miles per hour. Okay, so get to use a little bit of the area in that equation, finding the area of triangles and rectangles or parallelograms, and applying it in this equation. All right, areas of parallelograms and triangles, things you should probably know, but a little bit added geometry to it. All right, see you tomorrow.